group program manager for Azure Functions. So we're on the product team with Microsoft, based in Redmond, and we go to different locations to speak at conferences and just meet the local customers, local communities. So really thank you guys for inviting and coming and give us a chance to talk to you and hear your feedback of the stuff that we've been doing. But that's just my intro.
Sure. I'm Asavari. I'm also on the product team for Azure Functions. I mostly focus on languages for functions and experiences as well. Excited to talk to you all today.
So we have, this is not even a joke, we have 96 slides. Because we came prepared to talk about any different direction that we have on the product. We can talk about the current, the new stuff, and we have 6, 10 demos, different demos we can do. So, but I'll let you guys kind of guide us a little bit. So let's see, I'll do the opposite question just so I make sure I'm getting everyone. Who never developed an Azure Functions? We never created one, never developed. Okay, so that's a fair bit. Okay, good. So we came with the script though, so don't worry about it. So the script, if you go to script, and again, feel free to interrupt, is we're gonna go a little bit to the developer experience. Azure Functions is a product for developers. Although we're also going to talk, is also a product for data scientists and for IT pros and for system reliability engineers, but mainly developers. So we're going to go through the developer experience, inner circle, outer circle, like how you create your first function, how you deploy production. And then after we do that for a bit, then we go into the new features, what's coming, what's the latest. We're even going to talk to you, again, don't tweet too quickly about things that are going to be released in the next 24 hours. We're going to show it today. So, so that's sort of the script. But again, let me just do another thing. Like any particular topic or question you want to make sure we hit, so we don't forget. Anyone has anything they would like us to talk about? You guys are a shy crowd. Things like, do you want to know about code start, for instance?
Logic apps in combination with Azure Functions.
Logic apps was Azure Functions. Okay, yeah?
Maybe in combination with Louis.
With Louis?
Okay.
Yeah, okay. She's actually, sorry didn't give enough credit. She's our machine learning plus serverless specialist on the team. She came to save us. We had really poor Python support, really embarrassing actually. And she rebuilt the whole Python support we have and the integration with machine learning. Okay, someone else had a hand.
If I build a system with several functions, maybe 100,
Yeah.
will it continue to work when you change implementation?
Depends a lot on you. But
So there's a catch.
Yeah, we can talk about how to manage large scale systems too. And interesting enough, today we talked to one of the Azure customers, and for their APIs, they have over 200 functions. They all log in the same place, and managing them is more challenging than when you just have a dozen. So I can talk about that too.
And over different functions system time.
Over different.
If you ask 2 Azure Functions, what time is it? Does it give it the same output in milliseconds?
No, because you can't guarantee the execution. But I'll talk about durable functions. Might clarify how you can do. If you want that guarantee, I can tell you how to do it. A normal function execution is not guaranteed to execute at any given time. But
No, if you ask him what time is it in code,
What's the system time?
what's the system time?
Okay. It will give you time according to what the machine that's running. I can explain how this works.
Cluster computing for scientific research, maybe data analysis, but in scientific research.
So you need us to cover big data analysis for scientific research. Okay? That's all the hard questions I have.
I think I saw that you also support that absolutely for containers.
Yes.
Official
Yes.
Function container.
Yeah. Yeah. We can talk about functions, containers, and even Kubernetes too, if you guys would like.
I have used functions before, but I never used
The containers one.
the
Actually, one Asavari has its functions on containers, but I can either whiteboard, or we have slides actually. I can show the architecture, how we run layered on the container, and I can compare how we layer it on Windows, which is different.
Yeah, that would be good.
Okay, cool. All right, only 10 more questions. Okay.
Azure Function in connection with Service Fabric.
Azure Function Service Fabric. Yeah. Okay. Yeah. You guys know more than me. Okay,
I don't think you need to do the intro slides.
I know. I'm just gonna skip all of that. Yeah.
Can I communicate with Azure Functions with a GraphQL interface?
Yeah. Yes. Actually, there's a that I don't have slides, but there's actually recently released a really good series of videos of functions, GraphQL. You've ever seen Simone's videos and Burke's? I've seen the links. Yes.
How do I control scaling so I don't kill my storage?
Yes. Yes. We'll talk about that when we talk about premium functions. Yes.
How does the pricing work for premium functions?
Pricing. Yeah. Once I do premium, I'll talk about pricing too. Yeah. Yeah. All right. 6 more? No? Okay. Good. All right. Excellent. I did all the hard work. Let's get started.
All right.
Thanks.
I think one of the questions was about logic apps. So I'm just going to go ahead and just do a precursor for those of you who are not familiar with the Azure specific platform for serverless. And basically, as you'd expect, Functions is the very center of the serverless platform in Azure as well. Functions is the service that provides functions as a service. You bring your code to us and we'll host it in the cloud. But the question that came in was about logic apps, which is actually also a part of the serverless family. And if you're not familiar, what logic apps is basically a workflow orchestration service. So it gives you a pretty neat UI where you can build workflows from as simple as, hey, when I receive a new high priority email, go ahead and send me a Twilio text, to something more complicated like when a new lead in my CRM database arrives, I'd like to go ahead and send an approval request, and based on the response of that approval request, go create a new record in my project management system or something. Just creating a hypothetical scenario, and you're pretty much able to do all of that in a UI kind of view. So let me just switch to the logic app slides. And so this is the kind of UI view I'm talking about. You no longer have to understand for things that are more boilerplate, like send an email via Outlook or send an email via Gmail, or put a trigger on when a new item is added to my blob storage. We give you a UI where you can pretty much go ahead and pick a trigger and an action and build this UI in a more deterministic fashion. And the cool thing is you can actually create a workflow where you can even go ahead and add a function as an action. So you still have your standard boilerplate triggers and action, but if there's something that's doing, for instance, custom transformation, which you need to write your specific logic for in the language of your choice, you can even go ahead and add that custom logic to a workflow as an action. So that's how the functions plus logic app integration kind of work together. The way I like to think about it is logic app, if you don't want to go into the details, nitty-gritty details of the SDK, underlying authentication mechanism, worry about whether it's OAuth, AD, or the authentication provider or whatnot, just go ahead, use one of the, I think there are 200 available connectors in logic apps. And for anything that you want, which is more custom to your business needs, go ahead and use a function as a step in your workflow. So you get best of both the worlds, end kind of product being focused on the logic, your business logic and your business problem, and not boilerplate stuff. I'm not sure who asked the question. Does that kind of help?
Yeah.
Just a few more data points. Actually, the most common action on logic apps is to run an Azure function. Like as soon as your logic apps get complex enough, you need something beyond just what out of the box. Although there are 200 connectors, you still need to do your own thing.
Yeah.
And for that, when you come Azure Functions, one thing that's coming is when you create an Azure function, you need to go to Azure Function Experience, create, and then hook it up here, and then communicate over HTTP. We'll be able to create the functions inline right on the Logic Apps experience. You can write there, we're going to start JavaScript, just enter a few lines of JavaScript code as part of your actually configuring. So that's the other thing. But the amount of connections, like the amount of trigger types and actions Logic Apps have is something that without lines of code, it's very powerful. I mean, there isn't a parallel functions. Functions, you're going to put your developer hat on, and we help you a bit, but you have to code it up.
Okay, thank you.
Yeah.
Which actually pretty much leads us into the next question that someone had about Lewis. Logic Apps has a whole category of connectors that are actually the cognitive services connectors. So if you've already got an account with one of the Azure cognitive services, there are things like text analytics that can help you determine things like sentiment analysis, custom vision, which can help you do things like OCR. There's another, sorry, computer vision that helps you do OCR, custom vision that helps you do image classification. Those kind of APIs are actually connectors within Logic Apps as well. So if you simply wanted to use those REST APIs without having to call from within your function code itself, without having to construct the request, you could pretty much use the Logic Apps plus functions integration to make that call and then pass the response, say from Lewis to your function to use. If not, you're always welcome to go ahead and make those REST calls from within your function. That could be actually a REST call, or it could even be you using the SDK itself, the Cognitive Services SDK, to make the call to the underlying API. I think it was your question, so I'm looking at you, sorry. Yeah. Does that help?
I can do the check marks. So you can go there, so. Oh, this feels so good. Okay. So helpful. Okay.
Okay. So next one was containers, right? So a little bit of background for those of you who are not familiar. Functions actually has two versions. There was a V1 version, V1 runtime version, which was basically the runtime built on .NET framework. And then our team went ahead and did a bunch of work to actually enable an Azure Functions V2 runtime that's based on .NET Core, which was pretty sweet because it gave us the capability of not just develop on any platform, but also host on any platform. So traditionally we were only doing Windows, but then we also opened up to an entire new SKU of hosting options that are more Linux specific. So much that we can pretty much now say, hey, you can run your function anywhere, as in if you're developing on a Mac OS, Linux, Windows machine, you can run the runtime locally anywhere, it's open source. But you can also go ahead and containerize the runtime and your function application to run on a container hosting service that we are providing, or even on an IoT device if you wanted to do that. So that's kind of an overview of how we think about containers. At the end of the day, at its core, it's the open source runtime, which enables us to basically containerize functions.
We're maybe 8 or 10 that never create the functions. Maybe we create a Windows one before we go to the Linux one, and we start with the more
Okay, sounds good.
traditional, the first one of the family, then to the new members.
Okay. Do you want to do portal first, CLI?
Sure, do all of them.
Okay.
Portal, then we do CLI and VS Code. I'll go next. I'll go last with VS.
Okay, sounds good. Okay, so let's try and develop a simple function first before we get into the container aspect of it. One of the cool development tools that we've got is the Azure Functions Core Tools, which is actually a command line utility. And it's pretty cool because it's basically the combination of two different things. It's the functions runtime available to you locally, and also a bunch of management commands that help you create new functions projects and functions starting from templates based on the available triggers. So let's go ahead and actually see this in action. So if I've got, let's go ahead and create a new function project. So I have function8. I'll go ahead and pick a language for my function project. So I picked .NET in this case, and then once I've got the function project, you're basically seeing the combination of a few different things here. We've got, let me open it up.
one question in between. This is also available, of course, for the Windows environment, the conventional PowerShell.
Yep, it's cross-platform.
Okay.
You can pretty much run it. In fact, they're available via the different package managers as well. So I installed it via Brew. You can install it using npm or chocolatey.
Or Brew install too.
Yeah, that's how I installed it. Yeah. All right, so for my .NET project that I created here, I've got a couple of basic things populated for me already. Some information about the packages that my project's going to be using. Host JSON file, which I can populate. Right now, it only contains information that this is going to be using the V2 runtime of Azure Functions, but I can go ahead and add extra settings, which we can talk about in just a second. And then any local settings or environment variables that my project's going to be using. So just setting the context for what a basic function project looks like, but really what we care about is not so much the project right now, it's about the actual function. So let's go ahead and create a brand new function. So when I do func new, thing I'm presented with is, hey, here are all the list of all the available triggers. And trigger is basically an event that takes place in your source system that has the capability to go ahead and invoke your function code. Today we support all of the triggers that you're seeing on the screen out of the box, but you can also go ahead and use many more triggers if you're using something like Event Grid that provides the cloud event format. So let's go ahead and pick HTTP trigger just for simplicity, and I can give it a simple name.
That's my favorite name. Function. If you do just enter function, I want to use it. No.
All right, so this gave us, this basically populated the following file. Ignore I haven't done a .NET restore yet, so just ignore the squigglies. But I've basically got a run function here which takes as input an HTTP request. And what you're basically seeing is I've got this method attribute which is of type HTTP request, and a few configuration details. Basically details in terms of, hey, if I'm securing my function with an HTTP endpoint, do I want to put it behind a public endpoint, a API key protected endpoint, one of the other options that we have available, etc. So you're basically configuring the trigger. In the case of HTTP, it's still relatively simple. You're specifying authentication, you're specifying what kind of verbs it actually is accepting. In the case of something like a blob trigger, you'd probably be providing more extra information, things like what container you're watching for, what blob storage account name, etc. Once we've got the HTTP request, the sweet thing is you can pretty much go ahead and use this method attribute in your function to do things like extract information from the query string, go ahead and construct an HTTP response, and finally return that from your function, which is basically the response of your function, the HTTP response. The good thing about Azure Functions being open source is you can run the runtime, the same runtime that runs in the cloud, on your local machine. So for the project that we're seeing on the screen right now, I can pretty much go ahead and F5 into this project to start the functions host and start the function on my local machine.
What are the security recommendations for having HTTP function in production?
So there are a few layers. So what the Asavari is showing here is the functions itself. The function is part of the function app, which is your unit of scale. And a function app can have multiple functions. So you can put a boundary at the function app level, which is typically your HTTP, the entire HTTP endpoint, and you can put, let's say, a security like Azure Active Directory. Make sure you're authenticated before you go in. Now, at the function, which typically, if you think of an API world, like it's going to be each one of your verbs is going to be a separate function. You can do different authentications there. So you can have API keys and things like that. So you can combine those two levels of authentication.
Do we need both levels, or like if we add AD authentication, do we need to use the function level?
It depends. Depending on what you do, sometimes you leave your get operation without an API key, and your post you might have an API key. So it's really going to be your choice. Some people even go the extra layer. They put API management in front of all your HTTP endpoints, and do like JOT token level of authentication API management layer. So there's a range of things that you can do. All of those are supported. It can be quite confusing because you have too many options, but it's different scenarios need you to validate at different places. If that interests you, have time, I can show how to lock an endpoint down to Active Directory. We have functionality to do this really easily with Azure Active Directory. We call it, internally, we call it functionality easy off. It's a joke, nobody got it, it's okay. It used to be 12 steps and we reduced to 2 steps. So we named the feature easy off. Dang it, tried to jump twice, didn't work first or second time. Okay.
Alright, sorry. So we went ahead and started the functions runtime locally, and so what happened was now our function's basically running on a local host endpoint, so I can go ahead and actually test our function, and it should basically ask me for a query string parameter, and pretty straightforward. I go ahead and say hello. That's our very, very basic function. Same experience, we saw it from the function CLI, but you can actually also get a very similar, a much more non-CLI version of this from Visual Studio Code. So let me go ahead and actually open a fresh window in Visual Studio Code. And so we've basically got this extension in VS Code, which is the Azure Functions extension. And what this does is kind of makes it easy for you to perform some of the tasks that we were performing in the CLI itself with respect to Funkinit, starting a new project, adding a template, connecting to other resources in Azure, things like a storage account or a Cosmos DB. So much so that if you're not really a CLI person, if you're more of an IDE developer, it kind of simplifies things for you because now it has the context of your Azure account and your Azure subscription. So rather than saying, hey, I'm going to set up a secret as an environment variable, you can simply go ahead and say, hey, this is the storage account that I'm connecting my function to. So let's take a look at what the extension really does. The very first thing it does is, like I said, it has context of your Azure accounts. It knows what different subscriptions I have in my Azure account. I can go ahead and create a new project in, let's say, demo 2. And it'll ask me for the language that I want to pick for my project. We picked .NET before, let's go ahead and pick JavaScript, say. And then the same workflow, now it's going to ask me, hey, what do you want the first function to be? We can go ahead and, say again, pick HTTP trigger, give it a friendly name, go ahead and pick an authorization level, and then open the project. And basically when I say function project, by the way, function project is the equivalent of a function app in Azure. It's basically a set of functions that can share the same local and hosting configuration. So if you were setting up some secrets which were common to a function, or there was shared code within different functions, storing these in a single function app will help you kind of combine that logic into a single resource. So this went ahead and created a project for us. As I mentioned before, we've got our host JSON file, which is all the hosting settings, our local settings, information about proxies. If that's of interest, we can talk about it in a second here. And here's our actual function, the HTTP triggered function. And so what you'll notice here is this function structure for JavaScript is a little bit different than what you actually saw in the .NET template that we saw. And really, to kind of share with you guys, we typically try to go define the programming model for a language the way that language kind of prefers to do things. So when we spoke to JavaScript developers or Python developers, really the feedback we got was, hey, .NET, it's great to use type annotations and attribute, but as a Node developer or a Python developer, I actually like to keep my Azure Functions concept separate from my Node script or Python script. Right, so which is kind of the thing that you'll see here. There are no attributes or decorators anymore. What we've got is this function JSON file. This is the configuration where you will define things like what trigger you want your function to use. So the very same trigger that we'd seen in .NET, we've got the same exact trigger. We're defining a name property on the trigger. This is the name that we'll use for the method attribute in our function. So if you let me just complete this thought. So HTTP trigger is our very first binding. It's an input binding. And the other binding that we have is HTTP response, which we've also given a friendly name here. So if you go ahead and look at the actual JavaScript function, we're referencing the request with the name we'd given it in function JSON. The rest of the logic is actually very similar to the .NET logic we saw just in Node now instead of C#. Again, now we were looking at the VS Code experience. So the good thing about VS Code and why I actually might be a little bit biased because VS Code is my favorite tool for development is that we're giving you the functions extension for a lot of management operations and to help you run functions locally. But VS Code also supports a lot of good extensions in terms of the Node extension, the Python extension, the .NET extension. So you can actually use the goodness of those debuggers and just IntelliSense and autocomplete and everything those extensions have to provide in conjunction with the functions extension. So if I go ahead and in fact say set up a breakpoint in my code, I can, and then F5, this will pretty much start the functions runtime on my local machine, go ahead and attach the functions process to the Node debugger so that now when I call this function, what did I do wrong?
Do you have the other ones still running?
No.
The CLI one?
No.
Oh, that bug's fixed.
All right.
You need a new version of Node.
Okay. I
Or
was
an
doing-
older version.
Okay. You get the point. I'll demo with Python in a little bit. That's a little.
You, how many of you use VS Code as primary IDE? How many VS? It's mostly VS people.
Do
Okay.
you want to do a Visual Studio?
Sure, I can do VS. And VS is gonna work. This is, and then everybody's like, "See, I told you not to switch to code." Okay.
If you're sitting on the back, there's chocolate in it, so watch out.
You just push it once. I already installed it and it worked earlier.
Now do it. No, please open the file. Click share drive and start the software.
Oh, I thought I had done it.
You might need to install it. When it stops blinking, yeah, now you can go.
So, alright, so this is same idea with a professional IDE. I know. I have a lot of friends who work for Visual Studio Code. They would kill me if they hear me saying that. Recording Visual Studio Code rocks. Okay. Okay. So you do new project. If I can see, I will look at my screen because that's much smarter. Okay. You do new project. You have functions project. The functions logo. You can pick the programming language. You could you pick F# too? No?
No.
You'll be able to pick F# soon. as soon as our contributors contribute to it. And then you can pick the trigger just like you saw what Asavari did. One thing's worth calling out is the reasons we like showing all these different experiences. I think we might show Porter or not, is we made sure the templates in the experience is the same. All of them, all those environments use the function CLI as the base and use the same set of templates. So you get equivalent experience no matter where you go. And everything's open source, like even the template library is open source. So this is the same HTTP trigger. I never been scared of running this demo, but Asavari's one didn't work. So you could run. And
I don't run Node every day. I was trying to be nice.
We've been doing .NET. So this will get a window, invoke the func CLI, same thing. It's gonna stand up in local HTTP endpoint, and you can query that endpoint. It works 60% of the time. Here. Yay. Okay. So that's the same idea. It's nothing really magic here. That's not my name. Okay. And then you can you can debug and do all the normal things you guys do with with Visual Studio. Visual Studio has a few more things. So a lot of the things we do, the integration with Visual Studio, is based on app service as well. So you can get now remote debugging, snapshot debugger, some things that's unique to Visual Studio that you wouldn't get anywhere else. So yeah, so if I do this again, it should stop at my breakpoint. Then I could keep going, get my variable name, etc. You could also, the other thing that Fabio, the developer on our team, is you can actually step into the functions runtime code as well. Not for everyone, typically you wouldn't need it, but if you do need it, know what's going on, you could do that too. So that's another thing with Visual Studio. I mean, you could do the VS Code too, but it would make it easier to do it here.
Can you do it in JavaScript?
Can you do it in JavaScript? You can. JavaScript works as well. Just we run a lot of demo bits ourselves. So okay, should I go with something else, or you gonna?
We're to containers next, because we're trying to build up.
Yeah. Do you have slides on the architecture? How we run? No, I'll just.
Yeah.
Okay. Three. Yeah, but I want to do Windows first. Okay. I'll try to. I might use this thing here. Be a little small, but I'll try. Because you typically, if you hear someone talking about functions, they typically wouldn't know how it's implemented. So I'll tell you how it's implemented, and it's going to make sense why you care. I'll start with, we're a global infrastructure. We run on app service on Windows. That's the main offering of functions. I'll switch to Linux. I'll give it to Asavari to continue on Linux, but I'll do the Windows platform first. That's the first one we came up with. So Azure has like 50-something like different data centers across the world. Tons of regions. In each region, what we do is we create, for app service, we create a set of machines, typically 1,000 virtual machines that use for app service. How many are familiar with app service? Okay, most of you. Great. So a lot of those machines, we keep them available. Some that are sold, customers have bought them, and some are free for us to be able to deliver on the promise of infinite scale of the cloud. It's not infinite. There's a buffer, and you can only go up to the buffer. But that buffer, when it's not in use, Azure Functions also uses them. So when you go and execute your function, this one wasn't a cloud one, but if it wasn't a cloud, an event happened, we grab one of those instances and we run an Azure function. The way we run it, because I don't have a slide on that because I never built this, at the bottom you're going to have like some piece of hardware on a rack, and I don't know how to do a piece of hardware, and then we virtualize this environment into several VMs of different sizes. So you can have a VM medium size, and you can have a VM small, VM small. The small VM only has one core, and you have up to only guaranteed 1.5 gigabytes of memory that we can guarantee on those. On top of this, we do a sandbox where we run our function. If you guys are familiar with sandboxing technology, this is process isolation technology that prevents one process run a VM to access things that the other process can do. So it gives you that full isolation so you can do true multi-tenancy on our platform. if you're familiar with those technologies, there's one Microsoft called Drawbridge. Anyone knows Drawbridge? So there's one. Ours is not Drawbridge. Same concepts we call it Pickle Sandbox. I don't even know if we trademarked that name. I don't know, but anyways, that's our sandbox here. We have documentation on the wiki, what we do and what we lock down, but we lock down a bunch of stuff that you can do. For instance, sockets, the amount of sockets you can have, the amount of connections, there's a bunch of things you can't do. Or ports you cannot open. So that's how we allow, we restrict you to only do things that we think you can do. So you can install your own custom software, etc. So here on the Pickle Sandbox, and now I'm going to expand this. So now on the Pickle Sandbox, what you have is at the very bottom layer, we have our SDK running. So it's called WebJobs SDK. Functions was born out of WebJobs. WebJobs is a concept from Web Service. Existed as something that could run because customers were paying for those VMs on Web Service, but they said, hey, can't I also run my code? A lot of the initial use was, can't I clean up my logs? Can't I output my logs from my web app somewhere? Can I run this on a schedule? That's how the whole functions thing started. Oh, this could run based on a timer. This could run based on an event. That's how it started. So it's still called WebJobs SDK, but you can think of it as Functions SDK. On top of it, we run we have our runtime, so it's WebJobs, but I'm going to, for simplification reason, called runtime. When you see host.json, .json stands for it's the same thing essentially. So that's our runtime and host, and that's our code, the function runtime code. Your code runs on top of it, and your code is going to be source and config. Most of our config, like Asavari was saying, is JSON config. There's config at the host level, that's the host.json, and there's config at the functions level, that's functions.json. So that's our Windows stack, very poorly drawn, and you can barely read from the back, but it's the way it works on the platform. Any questions on this?
Is this the V1 or the V2?
This is on V2. It's the same. The only thing that changes here is this runtime host here is .NET Core in V2. That's one of the big changes. And now your source code does not run in the same process, runs on a separate process, and they use inter-process communication to communicate between your runtime with your process. As long as it's not .NET. .NET still runs on the same process. Any other language, JavaScript, Python, Java, PowerShell, they all run separately. They do inter-process communication. That's part of our language extensibility model. I ran out of space to problem. Any question on the architecture? Now the only reason I'm showing this is I'll contrast this with the Linux architecture that actually has a nice diagram. You'll be able to visualize it better. Oops. Here. Actually, the lights on. Oh. No, I didn't. I was afraid. My press on mine made me reinstall the whole time.
It's blinking, it still needs to.
Oh, you have to install every time? Okay.
Maybe, I'm not sure.
Installation is good. So this is the other reason this is going to make sense in terms of the VMs here. I didn't draw all of them. There's small, medium. There's.
Sorry. If you press the button. Hey.
Anyways, I'll explain that later once I get premium functions.
All right. So the Linux platform. This was the Windows architecture. The Linux platform is a little bit different from how Windows works. In Windows, the base unit is basically a VM. On the Linux infrastructure, our base unit for something is basically a container. So a little bit same in the lower level of the stack, which is we have a host OS. Over that, we actually have the Docker host or the Docker engine, which is going to be running the containers, over which we can go ahead and run a functions container. Reason I'm kind of showing two sides of the slide is because we sort of operate in two ways in the Linux world. One, hey, you still bring your application code to us. You say, hey, here's my function. I just need it to run on a Linux-based hosting platform. Take my function script, take my binding configuration, go run it. which is kind of the first diagram that you're seeing. Underneath the covers, everything's still running in this architecture where we've got the Docker host running on our OS, and we have a container that's got the language framework that you want to use for your function app, the functions runtime, which basically contains both the functions host and the language worker process. And we basically will go ahead and run your function in this container, right? There's also a second option that we have available, which is, hey, in case you care a little bit more about what goes into the container, maybe because you're using a different version of a certain language runtime or a certain different distribution, even if not just version, or you need to go ahead and install certain apt-get dependencies or drivers that are not just an npm install or a pip install, for instance, you can go ahead and bring the entire container to host on the functions platform. And we've got all of the Docker images that we actually run on the left side of the house available publicly on Docker Hub. So you can pretty much go ahead and say, I'd like to extend the Azure Functions.net image to actually add my own dependencies, add whatever custom logic that I need, customize that, build my own custom image, and then go ahead and deploy it on Linux. And in fact, it's pretty simple because the developer experience that we're providing kind of simplifies the whole task of having to build a Docker file in this context. So pretty much, before we did a func init, if I wanted to create a container, now I can simply go ahead and add a --docker file, Docker flag, and this time say let's pick Python. Let me create a virtual environment. So same command that I was running before, I can go ahead and use the --docker flag. And this time, it not only created my host file local settings and requirements.txt, which is the requirements dependencies format for Python, but also populated this Docker file. And so if I look into the Docker file a little bit deeper, you'll see that it's actually referencing the publicly available Docker image for Azure Functions Python on Docker Hub, or in MCR in this case, and then I can go ahead and copy my function app files into the container and install any dependencies. Of course, I can go ahead and extend the Docker file as and when I like. Once I've got this, you can either use the CLI commands if you're familiar with them to build the Docker container. Again, Visual Studio Code actually simplifies a lot of this for you because you can pretty much go ahead and say, I'd like to build my image and give it a friendly name and go ahead and actually build your custom image. Quickly, also switching over to the portal. Now, traditionally, when Linux was not available, all you could do was go ahead and create a Windows function app. With Linux, as I mentioned, we've opened up the possibility of you having to bring in your code or a custom container. Now you can go ahead and say, I'd like to actually use a Docker image, and then you can pretty much configure where you want to bring in this, this custom image from. So whether it's from Docker Hub, from ACR, or even a private registry, all you need to do is bring in the name of the image and any authentication details if those are needed, and you can pretty much go ahead and spin up a container in functions.
Is there any documentation on the Docker images? Because when I last tried it out, I ran it and it wasn't outputting anything. There was no logging at all. I was running it on my local machine, and I couldn't figure out how to turn on the logging. So
you deployed and didn't trigger, and you didn't know what was going on.
No, it wasn't working, so I wanted to find out what was broken, but I couldn't find any good documentation on this setup.
Right, the documentation for the custom image on Linux, this is the one, and I know it's recently been updated as well. So I'd go ahead and give it a try once again. I think I know the logging issue that you were talking about. I myself ran into it a few months ago. I believe that's been fixed. If not, go ahead and file an issue. We're super active, a little too active. We should have a life and not live on GitHub.
In the end, I figured it out, but I couldn't find any documentation on it. So.
No, and it has been. We've been running it as a preview. As a preview, we evolved quite a bit and
Yeah.
fastly. So it might have been just things that we needed to do. And
Yeah,
hadn't
yeah.
happened yet.
I don't think I read this, so maybe it's new since I first started.
Yeah, it's interesting if you just go ahead on the docs and look for Linux. This is one of the options available, so you can try it out. Yeah. So that's containers. Any other questions on containers specifically?
Should we do outer loop? Okay, for those of you that never created a function before, do you feel like you could create one if you tried? Okay. Okay. Yeah, that was a bad question. Okay, I'll try again. Do you guys also want to see like us created from the portal, or you feel like you've seen create? Anyone wants to see a function created from the portal? Okay.
Yeah,
Me
sure.
neither. Okay. Oh, you once said yes. We can.
Do you want this one?
Or should we do outer loop? Or
Okay. I can do this one.
and then you pass it to me to do a mounted demo.
Okay.
Let's do our loop. We can go. We're gonna have plenty of portals, so I can do an overview or Asavari.
Okay, I'll just finish that thought with the slide actually. So we looked at a bunch of development options, and really one of the key takeaways is we've actually got a whole matrix of options, and generally our approach towards the development options has been to try and meet the developers where they are. So, you know, if you are a Node or a Python developer, we try to do the Visual Studio Code and emphasize that more. .NET, of course, Visual Studio is the place. And then if you're a Java developer, we're trying to build more integration, deeper integration with IntelliJ, and obviously have the Maven experiences available as well. Nothing more on that.
Any plans for Visual Studio for Mac?
It's support on Visual Studio for Mac actually.
It is?
Yeah, even the V2 run it.
So remote debugging, is that debugging while it's deployed in Azure?
Yes, remote debugging actually works on if you've deployed to an app service plan, not on the consumption plan. Consumption is basically our serverless scaling plan. In that case, it becomes a little bit harder for us to deterministically say what instance your function is running on. But on the app service plan, where you have dedicated hardware, you can pretty much go ahead and remote debug your functions. And so when we think of the development process, we basically think of it in two paths. There was the inner loop, which we already saw, the code run debug. That's what we've been talking about for the last 30 minutes. But once you've already got your function running, the next step is to go ahead and productionize it. That's when you want to think of checking it into a source control, building a CI/CD pipeline around it, maybe splitting your traffic into test slot, production slot, so you can actually iterate and update your applications. And finally, the most important one, which is observability, or broken down monitoring and diagnostics. With functions, we provide a DevOps integration. Are many of you familiar with Azure DevOps? Got it. Okay, so we're actually integrating with DevOps pretty deeply, so you can go ahead and set up CI/CD for your function apps from actually multiple client touch points. One of the ones is the DevOps portal itself, devops.azure.com. There's also an Azure DevOps ability to be able to create a resource within the Azure portal itself. And the third one is from the functions experience itself. So let me go ahead and go back to the portal, for instance, and I can open up my dashboard here. Alright, so I've got a Node app in the portal right here, and the very first thing, for instance, I'd want to do is deal with a little bit of cold start. And once I have that, I can go ahead and say, hey, I'd like to create a new function. Say I pick in portal, I can pick one of the other development options. The next step I have, sorry, I'm in the wrong.
There you go. Oh, from the deployment center on the left. Down, no, up.
Oh, okay. I can see the UI. Anyway, so that was the portal create experience that you were seeing. What I really wanted to mention was the source control bit that we spoke about. So basically, if I were to say, hey, I want to configure an app that's, for instance, in GitHub, I can go ahead and use the deployment center to tie into my GitHub.
Yeah, you can continue instead of changing.
Oh, did I change it?
The two buttons.
I can go ahead and pick GitHub as the source for all my function code. I can go ahead and say, hey, I'd like to use the Azure pipeline if I want to use DevOps. We also provide an app service kudu build server experience. So if you're looking to do something more out of the box, such as an npm install, kudu would pretty easily be able to do that. But if you wanted to do something a little bit more advanced, taking advantage of all the capabilities that Azure DevOps has to offer in terms of release management, you can go ahead and pick an Azure pipeline. And subsequently, go ahead and pick the different organization, repository, etc. I won't configure this right now on the screen, but you kind of get the Uber idea that instead of you having to manually go into DevOps, understand a bunch of DevOps concepts in order to simply configure basic CI/CD for your function app, we're trying to integrate within Functions UI itself a deeper DevOps experience, so you're able to more naturally set up some of these CI/CD workflows. And then monitoring and diagnostics. You want to take those?
Do I know what the slides have? Okay. How many of you use application insights for Azure Monitor already? So some of you. How many of you seen the application map for Azure Functions? Some of you. Okay, so how many of you were at the serverless days on Friday? Okay, just you. Okay. So the demo is for everyone else. One thing, and Asavari kind of hinted to it, is Azure Monitor is really powerful. It's actually multiple tools in one. There is metrics, there is telemetry, there is the log analytics, there is the ability to do queries, and there's all the fancy graphs and UI that you can use to explore your application. This is an example of a query and can render a chart, right? But let's see this in action. I think it's more fun than this. Hopefully this thing doesn't ask me to install it again. Otherwise I'm going to think this is some sort of Trojan horse thing. Okay, installing it again. Okay, I'll let you use it. So the scenario I want to figure out here is, imagine this really happens in real life. You've been called 2 a.m. to fix a production bug. It's funny, on our team, although we're PMs, we used to be on call as well. So people would call us at 2 a.m. to fix customer code bugs. But anyways, I digress. Imagine it's actually my bug, my app that I do care a lot. And then I'll have to fix it in production. So a typical function, this is the Trojan thing. The typical serverless application consists of multiple functions, like a lot of them actually. We talked to a customer who was saying like has 200 functions. We just talked to them today. And they all log to the same place. And it's really hard when you see something fail, that could be a chain of functions, they communicate to each other over a queue or something, for it to visualize what that is. So some of you have seen it. So, but I'll show like the one application map I have here. So we have this thing here called the application map. And in that, based on the log telemetry of your application, it draws this neat chart here. And you can render in different ways. But pretty much it's going to put, for each one of the function apps that you have, it's going to say how many instances we're running, how long it's taking for one function to communicate to the other. Again, it could be via service bus, it could be just a straight up queue, event hub, you name it. How long it's taking on the messaging channel, as well as how long it's taking on the function itself. And you can see where there are failures and you can investigate. So once you can, let's say I was woken up, there was a bug, I could come straight here and say, okay, what are the things that are failing the most? And this thing here would say, hey, these are the top failing requests. Also, you can investigate performance. You see the duration. It takes a lot of things, and a lot of this is based on analyzing the code and based on sampling some of the data. You could go to analytics and query it yourself. If you feel self-sufficient, you know which query to run, or you can keep using the UI to dig in deeper. If you click one of the failures, it shows the request failures as well as the execution time, and show the top exceptions that you're seeing. And you could go further and look into those exceptions. So this one's message actually here. And then you're seeing like an error here. You could, and again, it samples and suggests one for you to look into. You can click on those exceptions and dig in further. This is probably my favorite view here, where you can see everything chained from the function that called to the messaging layer, all the way to what's actually failing in your code. And then you get details on the exception here, all the way to get a full on stack trace. And that stack trace has all the runtime stuff, like you've seen running at the bottom of Visual Studio Code. Or you can just show like the part that's your code, and even show the line of code number of where something failed. So you can go and debug and go into your code and try to figure out what's going on in your code and fix it, redeploy and all that. But that's one of the things that Azure Monitor does. There's a bunch of other stuff. I'll show some of them quickly. So I showed the application map. There's this application dashboard here that puts everything into a single place. How many servers were used for this execution, how long, how reliable it was. The other one I like is actually the analytics one, where you can run your own query. So you come to analytics. When you saw that chart on the PowerPoint, is analytics, where you can run any of these queries here. There's a bunch of pre-cranked queries, or you can write your own. So you could see the most recent exceptions with this query here. So you see those exceptions with the details. So you're free to do, and you can also render it as, you know, time chart, whatever you want. So you could see this in different ways. This one's not going to be interesting, but you can render in a way that's meaningful for you to see what's going on in your code. So it's really powerful. None of this is for you because you're already using some APM. You're already using like Splunk or Elastic or one of those. You can also export the whole telemetry and then pump it up through the system that you're used to. So there's this out of the box. When you create a function app, we create a Azure Monitor or Application Insights instance by default. But you can also just export without even using any of this. Actually, the export functionality is on preview, private preview right now, hitting public preview soon. That was monitoring.
How much do you get for free without modifying the code, and how much do you need to add additional code to do?
So what you're seeing here is without writing anything on your code, but you're in terms of true cost, you're now also paying for Azure Monitor costs because you're logging that telemetry to Azure Monitor, so you pay for it. So some of the folks already pay, let's say Splunk, Elastic, one of those. They can not use this functionality and just get the logs and export to another tool and do all this analysis elsewhere.
But if I want to trace the call between multiple functions, what do I need to change in the code for?
That one that I showed you, there was no change in the code to do that. We're correlating the calls using on the telemetry itself. As we know,
correlation ID are automatic.
Yes, but you're not doing the correlation ID. We're doing it for you.
You mean without Azure Monitor, just application insights itself?
And just like if I already built something without taking into account monitoring, like how much do I get for free, or how much?
Yeah, this is all what I showed you. What I showed you, this is all for free. There was no additional thing you need to do in code.
Just turn it on.
Yeah.
Even turning it on, actually, we're doing some experience revamps where we're trying to enable it by default for most users because it just makes sense for a majority of our audience, and instead make it an intentional toggle so you go turn it off if you totally want to. But pretty much everything's going to work out the box out that default.
So if you do like production stuff, we super strongly recommend, like when you file support case on us, the rare occurrence that we do fail as a platform, there are support cases that you file, and the first thing we're going to ask is what are you seeing in your logs? So if you have this turned off, you don't have any logs to look into. Like there's very little for us or you to work with. So if you're using functions for production, you need either some other APM or this one. Like you just otherwise you're almost flying blind. And you're going to rely on us calling Microsoft to go retrieve logs there on our side. And again, logs on our side, we have to remove a bunch of information because we can't keep those logs around. There's some disadvantage there. We can't keep the logs for too long. Otherwise, the GDPR gods are going to come after us and kill us. Okay.
You want to do premium? Some exciting
As I'm
stuff?
here? Okay.
Yeah.
All right. I feel like 1/3 of the room knows all my secrets, and then there's 2/3 that don't. How many of you heard of premium functions? The 5 of you, do you guys want to contribute on this? Help me deliver this?
I've heard about it, but that's
okay.
I think it was mentioned on the stand-up thing you do, the videos.
Yeah.
Last time, I think.
Yeah.
We're just in backwards order. We're just getting really close, 24 hours away from going to public preview. So that's so we're kind of. It's more mature now. We have more scenarios. It's running well. At first, when we announced, was still pretty buggy. Should I use your slides? I don't want to go back. I'm going to use these slides. Okay, you guys didn't see this logo here.
I think a better way to start might be how many have heard of serverless cold start.
Sure. Yeah. I'm going to get there.
I'll shut up now.
Okay. Here. Okay. Oh, I should also close my email. That would be good, huh? Okay. Get out of here, Outlook. Okay. All right. Sorry, guys. Hi, Faz. Okay. So here's what happens on serverless. What people would like to happen on serverless applications. We all love the fact that there's nothing running when you don't need it to run. You're not paying. You're not wasting resources. You're not hurting the environment, whatever. So when you get requests, you want your service to respond to it. So in ideal world, what you want is the dark blue line. As you have load, the service to scale immediately up with no latency whatsoever to respond to that load. Once that server can't handle anymore, you immediately scale up to handle the additional load, and so on and so forth, right? This is the ideal one. There's no waste, no wasted latency. Everything's responding and scaling just enough to handle your workload. That's how we would all like to behave. But in reality, it's all the scaling, and that goes for our product, Lambda, every single function that's serverless out there. It is a reactive thing. You don't know when you're going to receive load in your application. So when you receive load, that's when a server is going to be allocated. Again, as platforms, we can optimize as much as we can, but there is a payment in price here for this spike here that you don't have a server. And that's the cold start. That's when you notice the first time you access a server. But that point does not only happen one time. Once you go on 2 servers, that's going to happen again. 3 servers is going to happen again. A lot of people, the competition, puts the slides up, say, the killer of cold start is to write a pinger. So you keep your application warm. The pinger only works on this scenario here. The pinger will not want to work in any of the additional ones when you do your 3 ones. Unless your pinger is super aggressive that keeps 10 servers up. Then it works for 10 servers. It doesn't work for 11. So
kind of defeats the purpose.
But they have I'm not gonna name it. They have full slides on pingers, and it's really sophisticated. Without naming them, you can use CloudWatch to write those pingers. So now what we did was, and again, I understand some people got nervous. This is not serverless the way I understand serverless. Doesn't matter. It's a product that we need, or problem that we need to solve. Customers need it. This is based on us talking to customers, and they need this problem to be solved. A lot of scenarios cannot be handled if you have a full second of latency. They need to stay really low latency. The way to prevent having latency, you reserve instances beforehand. You create this buffer. You're ready to go at all times. You're ready to have a server there. When the load comes, that server starts processing, we put another server up immediately. So we keep that buffer up. The second server starts processing, we put the third one up, and so on and so forth. So it's like n+1 servers from what you really need. So you always have this buffer between the blue line and the yellow line. And that allows for you to not have that latency, not having to write to pinger and all that. And I'm going to show how this works. And this is coming on our new SKU. Today you can run functions on consumption, you can run functions on an app service plan. You're going to have now a premium plan. It's similar to an app service plan if you're familiar with it, as in you're going to choose like the type of SKU of the machine I want, how many cores, how much memory. You'll be able to go to 4 cores, 14 gigs of memory. They run on actual decent hardware. Functions today runs on the simplest, lowest SKU hardware on Azure that we don't even sell to our real customers, but we do use it as an infrastructure team because we use the spare capacity, like I mentioned before on my beautiful drawing. So Premium Functions now runs on a hardware that has SSD drives, so performs much better. So let's see it in action, how it works. So to compare both things, I have 2 tests here. I have one that's going to run just regular consumption, and I'm going to kick off that test. And it's going to put about 800 requests per second. And if I get the right one, that was load. I should look at mine. Yeah. So this one, if I put the load right, the number of servers are going to go up. This runs consumption. And the servers, you see that they try to respond as quickly as you can. If we leave this running, might get all the way to 20 servers. Let's see how this is performing actually on consumption plan. So this is the requests per second, and here you get the latency. So every time I demo this gets worse. Okay, so so the latency now is over 5 seconds at some point. That's the worst case latency here. And eventually, once you have enough servers that are warm, this lowers all the way to 76 milliseconds. And the number of servers is going somewhere crazy, 18 servers, right? This is actually impressive. For a lot of scenarios, async scenarios, this is pretty impressive actually. And in case you don't know this, there's the unlimited scale is actually 200 servers. So if we were really aggressive, we get to 200. But again, you pay the price of the latency. So now let's see how Premium 1 works. Not on this window. If I go back, I have a Premium 1 here, which I'm going to run. This demo has been run 45 times. Okay. So I'm going to run it here so you can see how this one works. And this is Premium. There's one server already there for you. This server is ready to go, ready to process load. So as soon as I put this task through it, it's going to start to spike up the request rate pretty quickly. It gets to over 1,000 requests per second. And now if I look at this one here, the latency does spike, but it's a different ballpark altogether. It's 200 milliseconds, and that's the worst case. And we're hunting down our devs to flatten this, but anyways. So, but 200 milliseconds. Now you can think of interactive scenarios, really. You can think of scenarios that even a user could wait 200 milliseconds. I mean, we're pretty patient these days, but 200 we can handle. So, and to prove that this is much better hardware, this is the same code. I'm not showing, but believe me, it's probably some hello world. And it's 10 milliseconds the average latency on this function. This is because it's a much better SKU in general. So that's Premium Functions running. Now Premium Functions, it's way more than this actually. This is just the reserved instance aspects of it. Do I have the other Premium Functions slides? I apologize with all the switching slides because this makes us pause very unnaturally, but I might have it here. Let me do it here. I think I have. Okay, let me mention all the things. Let's see what I didn't limit. We didn't talk about. Oh, okay. So one thing, it was actually a question. One thing is you pick the minimum amount of instances, which is your reserved one, but you also pick max. Max is a big deal actually. A lot of serverless applications, they're constrained on what they call. The serverless application could go 300 instances, but they called some other API. The case we talked today was that some dynamics API. That if you call too much, you get throttled, or the calls are going to fail because you cannot have that many clients. Now, what you can do now with Premium, you can say, I only want to have this many executions in parallel. So it limits the outbound calls that you make with your function, which is something, it's an advanced concurrency control that we've been asked for a long time. Those are the SKUs that you can actually pick, which is the size of the VMs. Also gives you VNet connectivity, so you'd have that same experience even if you're talking to resources on-prem. So a normal function consumption, you cannot talk to on-prem resources. This one allows you to do that. And your function now can also run forever, essentially, because you're not, that hardware, no one else needs to, we don't need to sort of expel anyone and say, hey, you need to leave this hardware so I can put another customer in. This is fully yours. So now, not the bad news, but obviously you're allocating a server, now you're paying for that VM. So now there's a cost, there's a fixed cost for you to run premium functions of a minimum of 1 instance. And as you scale, you're paying a little bit more than the scale of consumption because you're scaling on better hardware. So the price point's a little higher, but you're only paying for what you use above that minimum instance. So that's premium. Do I have anything else on premium? Yeah, plain size control allows you to control your destiny. Wow. Okay, it wasn't me that wrote this. Okay. So yeah, that's premium. Did I miss anything on premium? No. Okay.
Is it gonna be cheaper running on Linux than on Windows? Does that matter?
Are you talking premium or functions in general? Functions the same price point, consumption, Windows or Linux. It doesn't matter. On Linux, a hidden secret is on Linux, I'm tackling another question someone had was, I'll let you do this while I talk. On Linux, we run on top of Service Fabric Mesh. For those familiar, there's Service Fabric. Service Fabric Mesh is the idea that you don't have to fully provision a cluster. You can get a node pretty quickly out of Service Fabric and use it. Our Linux functions run on top of Service Fabric Mesh. Service Fabric Mesh being a newer product on Azure, they didn't get all the legacy hardware that we got on App Service. Their baseline hardware is better. So a Linux function might perform a little bit better than a Windows function. I don't know if it's going to be too much better, but it's going to be a little better. I think it's going to be noticeable. That's what you notice with JavaScript, right? Yeah. So JavaScript, which is the one you can run on both, you can run that on both platforms, probably got a little better. But just a consequence of the platform baseline being a little better. But we don't make any guarantees on that. Like our guarantees are on the lowest common denominator. Premium functions, that's not the question asked, but premium functions will start with Windows and we'll have a Linux one too offering. So you'll be able to run like Python, that's crazy scenarios. I don't know, many of you are data scientists of models, machine learning models generate 10 gigabytes. So a consumption function cannot even load that much data. So a premium function will allow you to do those scenarios as well. So
what was the metric that was kicking off the scaling? So was it on the response time, or was it what was causing the servers to
it's a good question. So I'll give you a long answer. It's always based on the events that are coming. So in the case of HTTP, what we do is we instantiate a bunch of servers, and we have this component called a scale controller in our platform that's pinging those servers to see how responsive they are. If they're being slow to respond, we instantiate another one. So that's the algorithm we implement. So, and then if you have a burst of requests, we try to spread them out on the different servers. As soon as we notice they need help, we add more.
So that's the same if it's a HTTP trigger or a queue trigger?
A little different. Any trigger that's non-HTTP, like if it's a queue, we can look at the queue, how many items are in the queue, and how fast we're processing the queue. The queue is a predictable type of event, whereas HTTP is unpredictable. I mean, there's a queue length of HTTP, but there's only so much I can see. Whereas service bus queues, storage queues, even Event Hub, all of those, I can literally see how much items you have, so I can sort of provision a little bit more in advance.
So the maximum, how is that configured? Is it maximum use servers or parallel executions?
The maximum number of parallel executions is what we want to allow you to configure. But you can also configure maximum number of instances, which is servers. So both of them. And again, that was a much needed feature, like one that we got a lot of asks for.
It's off topic, but does mesh agree with those?
So I honestly don't know their dates, but they are. We run on them, and we need our Python offer to go out of preview into GA soonish, in few months. So I need that platform to be GA quality. When they're going to make an announcement, there's also a little bit of a marketing thing. What do they do about marketing? So I think they're also a few months away, would I expect. So they're considering that. There are a few other things. There is how they announce this, so it's not confusing some of the other offerings that we have. But yeah, they better be, is my point of view, because I run on that platform and I need it to be GA so I can stack my GA on top of their GA. So I just don't know. Sorry, it's a little open because I don't know. I actually don't know their dates. Any other premium questions? See what I did there? Premium questions? Okay. I tried so many jokes already. Okay. You ready before I embarrass myself?
What do you want to talk about?
Should I talk about this? Okay. You guys want to hear a little bit about networking? Networking? Okay. Yes. Okay. Good. 4 people. Okay. Good. Okay. So my preempt into this premium actually was a lot of it sort of motivated by networking. Like when we go, I don't know how many serverless conferences you guys attend. I attend one last year, Serverless Conf, probably the biggest serverless conference. And Verizon did this slide, which is shocking to me, which was, what do we love about serverless? And put all these different things we love about servers. And then it's like, why can't we use servers? And it was like this list of things, like networking, lack of custom encryption, lack of the security standards that we need, lack of some compliance certification. So, long story short, serverless on the enterprise needs a lot more things that none of the serverless platforms had. So motivated us to do a lot of things. In our platform, there's a lot of networking things we need to do. Today, a lot of the security is done at the networking level. So there's a lot of debate on, should I do security, like authentication, authorization? Should I do networking security, like fully isolate my endpoints? So we started looking into what we should provide there. So one of them that the customers wanted is not having any HTTP, don't have an HTTP trigger, having functions that they can call out to the internet, but they cannot be called over HTTP. So the way the functions typically work is, in our infrastructure we have HTTP front ends. They're shared with app service, and those front ends, they're shared app service, they're visible to the world. We cannot lock them down because you as a customer can't have control over what thousands of people are using. But what we can do is have some routing tables that prevent HTTP requests to be routed to your function. So that's how we can block HTTP triggers. So that's one of the things we can do, while still allowing your function to call out to the internet. So that's one of the requirements we have. And then what we did is, with premium and then service endpoints, what you can do is you can configure a VNet to only those addresses on the VNet to allow to call into your function. So we know just a generic request can come, but if you configure your VNet to be able to access that endpoint, you can do that. So you need to combine VNet with service endpoints. That's how you achieve it. The other integration we've done is sometimes you want to call into the VNet. It's probably one of the most common scenarios. You have some SQL on-prem that you need to access the content on your functions. So that's the one that you configure your functions to access a VNet. So you can do outbound calls that way. And then if you want both, then you configure the VNet integration plus the service endpoints. So those are sort of all the options you have. And then that's the one that's coming is, folks also want, again, the all enterprise requirements is don't allow the function to even call out. I want that functions to be fully isolated, if you will, like only VNet stuff in and out. So that's something that's coming, which is the outbound IP restriction, for us to say, hey, for those address range, which can be the whole internet, can be anything different than 10 dot whatever, and you can block all of that. So that's the only one missing for us to fully cover the set of networking requirements that we receive.
This is only will be for the premium functions?
Yeah,
or for
so almost all of them is for premium functions except this one. So today you can do already the IP filtering, which prevents this one. So this is in consumption. Sorry, I should point there. And then all the other ones is on premium functions only.
The one where you call out to a VNet as well?
The call out to VNet, that's a premium functions functionality.
This one?
Yep. Oh yeah, the other one actually, a lot of customers use it this way, but again, if we talk about price point, now it's a different order of magnitude price point here, but if you're familiar with app service environment is an app service environment that you fully own the front end as well as the workers, which are VMs where your code runs, but you own the front end and you pay for it. So you pay for a set of machines instead of just a few machines because you're going to pay for front end and another VM that's called a multi-role that controls your infrastructure. In that case, app service environment, you can even put your own firewall product in front of it. And some companies have that requirement. They want that level for isolation. If you provision something like app service environment, typically what you do is you put a lot of machines into it if you're a big company, and then you share with your company that environment, and that environment is fully locked from the internet. So that's the other option. Again, now we're talking, actually don't know, but I think it's going to be about 10 times the price of a basic premium function is what you're talking about, because I think you start with 8 machines or so. I can check my numbers, but it's a different, again, it's not for everyone, but a lot of customers do adopt this thing actually, more on the large enterprise. Okay. Good, networking, okay. More stuff for cover more questions.
Looking at this thing, I think the only one we have left is there. Anything you want to add to the list? I think we still have a bunch of time.
I have a question about service fabric.
Oh, sorry, we didn't talk about service fabric. We talked about mesh. What do you want to take service fabric?
It's a fabric versus functions. Yeah.
What I like is to, suppose it was remoting from a function into a cluster.
I don't think, we don't do any special treatment to service fabric. It just depends how these endpoints are being exposed. Then it goes to my network use line.
Use the same VNet, let's say, with a cluster with the functions.
Yeah. There's no difference. There's no special treatment either way we do service fabric. There's no special treatment we do with Azure service in general, except service endpoints that allow you to configure different Azure services to talk to your resources. But that's just for service endpoints. For us, it's just another Azure service.
I think as long as they run the same VNet.
Yeah, you'd have to configure the same VNet or allow the access, the VNet access from the function so it could call into that cluster. To make a call from that cluster, then you need the service endpoint from the cluster to the function.
But the other one from the function to the.
Then you just need to configure VNet on the function, then you can call down. Yeah.
The last remaining topic we had was big data and data analytics.
And I can do roadmap after that. Yeah.
Specifically, big data, we don't hear about as much as we actually hear about data processing and some machine learning inferencing scenarios. Popular one is either, hey, at the very beginning we talked about some cognitive services scenarios. Hey, I'm passing my information from like one service to the other, maybe for cognitive scenarios or other scenarios, and really I want functions to serve as the glue between different services where I'm doing some kind of data transformation or data processing. That's one. The other one is, hey, and this has actually started to become more and more popular with our Python offering, is, hey, I have some kind of a machine learning model that a data scientist developed and trained, but now I need to create a web application out of that, something where I can actually deploy that model in order to create an API out of that. So it's it's basically a web service that's making a prediction in the cloud. That you can do as a function as well. Do either of those scenarios, I don't know who asked the question. Oh, okay. Are those the kind of scenarios that you were looking at, or something a little bit more on the big data side?
Yes, it's like applying several scripts to a really big data set that cannot run in a single server, and then what applies to this technology to go forward. So is data processing, but for scientific purposes.
What's unique for scientific purpose? Like for just so we understand. Like for us, it's data. I don't know if is this heavy CPU, heavy memory? What's a property that will make it unique?
Well, the data is very large and it's a genetic analysis. Then the output is very large and the models could be applied. Yeah, definitely it needs a lot of computer memory and so on. So cannot run in units.
What we've noticed, I mean, not an expert, no, what we noticed talking to like some of the data specialists is this problem with models that are like over 2 gigabytes of memory. Like the function normally only have 1.5 gigabytes of memory. So they have a lot of models. Some of them are even, in the max on the premium is going to be 14 gigs. So, which they're really looking to, SKUs are even larger than that. So one thing, it's more roadmap-ish we're looking into is you could use functions and deploy to whatever hardware you want. Like potentially could deploy a function to like a GPU hardware even. Now you got the processor too, but you run functions in environments that can process more. But again, for us, the input is just input data. As long as we can load up in memory, the function should run. Consumption, execution can go only up to 10 minutes too. So if that takes a while to process, then you have other options, other things we didn't talk about, like durable functions, and you can break the data and do a map reduce on the data, and then process a bunch of bits in parallel, and then munge it all back together. So there's some alternatives on how to process large data.
I can show a quick ML demo if that's of interest. I think it kind of resonates with the scenario of large models that we were talking about. I just conveniently have it here open.
It's not ready at all.
I think to set context, we recently announced Python support for functions. For functions v2, so it's actually built on the v2 language extensibility model, and we realized clearly customer feedback was that we want to run Python on Linux, and that's our primary scenario. So this is based on the new Python support, and so I'll just show you a simple Python function. So I've got a Python project here, similar constructs as the ones we saw before. I guess a few things that might be a little bit different is I actually, instead of defining my dependencies in a .NET way, I'm defining it in a requirements.txt format with my libraries that I want to install from pip. Everything else in terms of local settings, hosting settings, environment variables, everything remains the same. In my function project here, I actually have a classify function right here. And let's take a look at the classify function. First thing, looking at the function JSON configuration, I think you guys are pretty familiar with it by now. We've set up an HTTP trigger for our function, and the actual Python script that I'll be using to invoke my function is the init file right here. So looking at the actual Python function, the cool thing is we've actually defined type annotations for you to use within your function body. Completely understood, Python does not have strong types, but really what we noticed based on user feedback was, hey, I don't want types to be required, but I'd love to get the autocomplete and IntelliSense when I'm writing my function code. It definitely functions users like the simplicity when they're developing. So anyway, go ahead and invoke this function on HTTP request. The very first thing that our function is going to do is initialize our machine learning model. And so that actually takes me to the model file I have right here. It's a protobuf file, it's a binary, so you won't be able to see anything, but I've trained an image classification model for my application. So essentially to navigate to this, I've got a TensorFlow model that I built using Python that's capable of doing image classification. So if I give it a bunch of images or pictures of objects, it's going to be able to detect what kind of image it is. For the purpose of the demo, I basically went ahead and used Cognitive Services Custom Vision to train a model that can predict the breed of a picture of a dog. So if I go back to my application, I've already got the model here, so I can go ahead and see that my initialize function basically goes ahead and uses TensorFlow to load up the model and any labels that it can assign to a picture that's available to me. Once I've done that, the next step it's going to do is to actually extract the URL of an image from the query string of the HTTP request, and then finally go ahead and call the predict function on the URL. And I won't go into too much detail of the predict function, but if you look at it, it's basically going ahead and transforming the image and converting it into a NumPy format that TensorFlow can actually understand. It then, once it's actually transformed the image, it'll go ahead and start a TensorFlow session, actually draw the prediction for the image that we've given it, and then finally go ahead and construct an HTTP response based on the prediction it's made. So it should actually give me the prediction it's made and the confidence level with it, which it's determining that prediction. That's pretty much it. Once it has the response, it'll go ahead and return it as part of the HTTP response. Now going back, we've got the functions extension that provides me with the functions process or the functions runtime, and the Python extension that we use for the actual debugging. So all I did to go ahead and run this function locally was simply F5 on VS Code running on my Mac. So if I go ahead and click on this classify image, let's grab the URL of this lovely poodle here.
Lovely, you said?
I think it's lovely. All right. Give it the URL in the query string. What we're going to see is in our logs, this should go ahead and do the resizing and the transforming of the image that our predict method was supposed to do. And finally, once that's done, it should go ahead and actually return the response to us in terms of what it actually detects. So our model's pretty accurate. It knows 99% it's a poodle. So that's pretty much the kind of workflow. And this is a more basic example, kind of trying to showcase that hey, functions, while a lot of times we try to use them for simpler scenarios, is also very handy when it comes to more complex processing, especially for folks who are maybe not mainstream developers, folks like data scientists who really don't even know what it means to go stand up a server or provision a load balancer or traffic manager. Serverless kind of comes really handy. So definitely useful in that context as well.
Cool. You guys want, I can do roadmap or durable functions? Roadmap? Durable functions? Not the same people, please. Like, good point. Let me try again. Roadmap? Okay, durable function? Okay, and I'll end with roadmap then, and then I'll have durable here for you guys who lost. I'm sorry, durable people. But roadmap one.
You have the roadmap side?
Yeah, because doesn't have all this stuff I need. Okay.
You have to install the Trojan again.
Yeah, I know. It is, man. This thing is like, can you install this software again? Like, yeah, sure. Install software, yes, yes, okay. So this is all, I can talk to you all, I'm not going to put a timeline, but almost everything you see here is like 3 to 6 months-ish, but I can't make any promises. Okay, this guy, okay. And again, joking aside, whomever is interested in durable, be happy to talk offline. Just so I'm just don't want to keep you guys for too long. Okay, let's talk about roadmap. Feel free to ask questions. So one thing that we don't like, and I know customers don't like, is if you use the functions on the Azure portal, the first time you will list your functions, that call takes forever. Most people context switch and will do something else, get a coffee. Because what happens is, today, when you do all these functions activities in the portal, we start the runtime. Those 5 seconds you saw in the demo, you're going to experience that just by trying to list the function in your function app. So you guys could ask me, like, dude, this makes no sense. Why did you implement it this way? It's like, I told the development team not do it, but they did it. Anyways, so we split. Now we did the control plane calls separate from the data plane. So what happens is we cache, because you don't change the function name at runtime. All this you do at the deployment time. So when you deploy new code, we're going to cache that information. When you go and list your function, the UX is going to be quick. So that's where we're changing the API and the way the UX communicates the API. So it's come pretty soon. With that, a lot of other operations that depend on the runtime, now it's going to be coupled. Some other operations, this is the most noticeable one. Some other operations will be quick. The other thing some people notice is the functions UX on the Azure portal looks a little different than a lot of the other things on the portal. And that's sort of by design because we did not have the controls you need the time we implement the function. So we literally put an iframe and did whatever we wanted. Our customers needed, on the Azure portal. And that made us create our own controls because you needed to code, you needed to see a log stream, you needed to test your code. And so we had a lot of custom components very unique to Azure Function, not the rest of Azure portal. Azure portal now has a components, so we're going back to standardize them. The first one you're going to see is when you do a new function app, it's going to look different. It's going to look much more the way if you create a VM today, or if you create some AKS cluster, some of them are only you create already. So functions will change that. That's the UX updates. Languages. So our GA languages, .NET, so C#, F#, and then JavaScript and Java. Those are generally available. JavaScript and TypeScript, yeah. And TypeScript's one that we announced recently. Python is on public preview, so it's the next one that's going to go GA a few months-ish. And PowerShell is the one that's on private preview and public preview very, very soon. Just one very soon. The next one that's coming, and it's going to be still this calendar year, is we're going to switch to the .NET Core 3.0. And we're also going to support the .NET full framework on top of the Functions v3. So Functions v2 today. At the time we do .NET 3, it's going to be Functions v3. And we're going to have also .NET full framework. A lot of customers will realize they don't move from v1 to v2 because they're running full framework. There's stuff that they use either anti-framework, Dynamics APIs, some APIs that don't have an equivalent on .NET Core, so they can't move to v2. So we're going to move it to v3. Okay. We have this, we can show. We have this thing that we keep doing, which is a community library. I can show it online in a second. Which is a bunch of sample code that we collect from the community and from advocates, which help you start your functions project without having to write a line of code. One that I like is this Stripe credit card payment. You can just click deploy, browse, type Stripe, deploy that code to your subscription, and it's ready for you. So and incentivize more of that. So if you have nice samples, contribute to the community library so other people can find it. We did a real nice UI, I'll show you in a second. Code Start, I talk about premium, but this is Code Start for consumption. It's something that I made a lot of jokes, but it's actually a very serious topic we need to get better. A lot of it is the hardware we run on, but I'm not here to make excuses, so we need to do performance improvement. So we do things like when to jet the code and things like that, when to bring lazy loading things. So there's people that dedicate their lives to lowering Code Start on functions, so we want to keep doing it. Asavari talked about DevOps, so Skip, I talked about premium. We have integration in Key Vault. There are a few more things we want to do. So today you can keep your secrets away from dev service settings, put everything in Key Vault, and just reference a key in Key Vault. However, if you version your secret, if you rotate, you have to also change your app setting to indicate which version it is. In the future, you shouldn't need to do this. If you rotate your secret, no changes are needed on functions or app service for that matter. Durable functions, for those of you that use it, those of you that don't use it, just super quick, durable functions are orchestrator function. I said earlier, functions only run for 10 minutes. Durable functions run virtually forever. So what they do is they have an orchestrator function that checkpoints the state of the execution, so allows it to, even when you kill it and you bring it back, it will know exactly where to continue the execution. Durable function orchestrator, just like Logic Apps is, that can pose into other functions called activity functions that are just normal, mundane functions that run for 10 minutes. So durable functions check state all the time, uses Azure Storage to do so. So there's a lot of I/O involved, and those are distributed storage type of I/O, which are expensive. So we're plugging in new storage types. So Redis cache probably be the main one, Cosmos DB, etc. And we're also going to make some Grav on APIs that we're going to make some breaking changes that we've been waiting to do. So we're going to release that as a separate version. If you have durable functions today, you can continue on 1.0, but 2.0 is coming. Something to know with some improvements. Support Center, I think I've mentioned a little bit. When you file a support ticket, again, don't do it. I'm sorry, team, they get stressed. But if you have to, when you file a support ticket, actually does go through your logs, the ones we have, we have on our platform, to indicate what could have been the problem. So things like, if we know that you're running out of connections or running out of memory, we're going to give you some recommendations before you even file a support ticket. So again, maybe not the sexiest feature, but actually helps a ton customers self-diagnose their problems. So we're going to keep investing on that. Functions for IT pros. Said this in the beginning. You think of functions for developers, but there are tons of customers that are automating Azure infrastructure, doing things like when start a VM, also register this VM with Active Directory, so other people can access it. So there's all this automation code that today it's typically written with PowerShell. But we didn't have decent PowerShell support in V1. It's pretty horrendous, don't use it. And then Vitio rewrote all of that to have a decent PowerShell support, actually written by the PowerShell team, which conveniently sits in the same building as we do. And that's the one that's coming. And we're also going to do deeper integration Azure resources with our PowerShell functions. The way it kind of looks like, we did the beginning of it's actually live, is this thing here that you see here, see events. So let's say you're in our Azure resource, no matter what it is, we want to allow you to trigger some other, manipulate an event that happens on a resource. When a VM is created, when a VM changes, you could write a logic apps or you can write the functions that does that. Eventually this function comes here, a window that you can write your PowerShell script that knows that in this case you're in a storage and you want to do something with that storage. Like change the replication type or whatever you want to do. So we want to allow for IT pros, SREs to really take advantage of the power of functions. Again, running consumption or running on a timer, whatever method you want it to run. Okay, now, let's see. Oops, no, there's not one more thing, sorry. Okay, Linux hosting, I think we talked a bunch about that. Kubernetes, this is more, it's more a history, sort of like teaser, the direction we're going, which is, for the longest time, as long as we could, we resisted going into the Kubernetes bandwagon because we're serverless. But it's unavoidable. A lot of our customers are doing Kubernetes, either because they want to be multi-cloud or they want to go on-prem the same way we go to the cloud. So they could host their own Kubernetes or put Kubernetes in their favorite cloud provider, typically Azure. So we're doing all the work to be able to deploy functions and scale functions in Kubernetes. So a lot of the things you see here, you'll be able to do even if your infrastructure is running Kubernetes. So the local tooling, dev experience, all the goodness we're known and do well, we're going to do that in Kubernetes too. For that, we're going to go even further with open source, considering donating parts of the components we have to open source and partnering with companies that have a tradition of developing on the open source. So we're going to do even more of that. That's a boring slide. Okay, that is the last thing I had, unless you have questions. Okay.
Could you share the presentation?
I can, yeah, I can. Yeah, there's, I mean, we have to.
Yeah, it's not a single presentation, but we can do something.
96 slides to
yeah.
Anything else? Who learned something they didn't know before? Oh, that's good. That was, you guys are so nice. This guy's really asking. Okay. So we really do appreciate. Thank you so much for your time. It's a pleasure.
Okay, so we have one small last talk. We actually within a factory use Azure Functions. I will walk you through how we use them. I'm sitting down because I'm a walker, and the cameraman, which is also me, doesn't like people that walk around a lot because then you need to edit a lot.
Thanks for not telling us that.
So yeah, we built Start a Survey, which is a way to, basically the sentence tells you a little bit about it. It would be great if you could, so what we do within a factory is build feedback tools which allow you to give feedback about your organization and how you work together with your co-workers. And we started building a tool which allows you to start up a survey for a team whenever you want it and in the way you want to do it. So on the right side of this, you see a small part of the front-end application, which allows you to select different kind of things, questions you would like to add to your questionnaire, and you could tell it, I would like to do this for this amount of people in my organization within this period, time period, and with these questions. Now, this is all the front-end. I'm not going to discuss many about that today. Because what we did was we built this, which is a lot, so I'm going to walk through it step by step. First go back to how we actually decided to pick Azure Functions. I will switch so it's less watching. So I think about 8 months ago or so we decided as teams within the factory to build more applications as microservices or smaller parts so that we're not all trying to change that same SQL table and fighting a lot about that. And different teams pick different ways to do that. We used Azure Functions, another team used web jobs for that to receive events. Another team used Docker and Kubernetes and not sure which applications on top of that, but we all did different things. But we had one thing in common, that was we needed to talk to each other. And we did that using Service Bus. So what we get is a lot of messages from different systems. So the participants that are in a survey will be sent to us from another system. The period selection or the way you can set up your period will be sent from a different system. And the questionnaire itself will be sent from a different system. So all those events come in and we process them to give you this portal itself. And we do that with 3 Azure functions. One of them receives messages, one of them processes them, and one of them updates the projections themselves. And I will go into them step over step. And we have 2 more, which are durable functions, which do the backup of things. So what you see here is we have different integration events. So that could be a participant is created within the system for this specific client. We all batch those up into a queue, a storage bus queue. We first tried to do this topic by topic, but then we soon discovered there wasn't a way to get them in order again. So we decided let's move them to a queue to have some sort of ordering. We have one Azure function. Basically what that does, it takes the message we receive out of the queue and stores it in table storage. We use event sourcing in Azure storage. And we do that by batching them up a bit, because if you need to do large sets of them, because what could happen is that if in the other application you press save, for example, it could do 20,000 events or something, because that's the amount of participants that people that you're adding to the survey. So it also needed to scale a bit. And what we do is we get that message, we post a trigger we trigger something in a storage queue. So we say, please show this after 10 seconds. So this is based upon, for this specific project, there is something that needs to be updated. So for example, that could mean that 10,000 participants are currently in table storage. We use for the partition key, which is the thing you do to look them up, we use the a set ID, so for example customer ID, which we also put in the trigger. and we log them to Azure Functions with the correlation ID, so that allows you to use the application map and to actually see what happens with that specific message over all the different Azure Functions themselves. Feel free to ask any questions during this. Yeah, so this basically picks up the message, sets it in the queue, and that means it's ready for further processing. So this could be batched up. Yeah.
One question.
Yes, sure.
How do you do the visible after 10 seconds?
Oh, sorry, we do that by using the storage queue. You can do that by default. You can put a queue message in there and say, I would like this message to be visible after 10 seconds. We used to have 1 second, but I think last week we decided to move that up to 10 because it didn't really matter that much. And it's only batching up more, so it's doing more work at the same time.
Are these separate function apps, or are they all in the same function app and they're just separate functions?
They're all in the same function app, right?
No, they're
No.
separate.
Oh, separate.
They're separate.
Yeah, so we end up at the event processor, and what we do to store them is we have an event store, which is a block document, which will basically store the project ID and the event ID. This is the ID we use for ourselves to have something which is more like 1, 2, 3, 4, 5, which is counting up instead of a qubit which comes from the message ID which we receive from Service Bus itself. So what we will do is lock or have a lease on the blob storage. This allows us to process only that specific customer or project or thing we want to be, we want to keep ordered. And so let's say, for example, customer 1. I'm going to walk. Let's say, for example, customer 1. And what it will do is get this file, lock it or lease it, so no other Azure function can access that specific project, get all the events that belong to that specific project, and process them. And that means it will store them in table storage. That's our event store. This is all done from the trigger that's in the queue itself. And it will tell the projections to update, because we have, which is something I should have explained a bit more up front, we have JSON projections which we use to basically serve things to the front end. Yeah, so everything is, each time we need to do, so table storage only allows you to do row key, partition key and row key. You can add more columns, but this is the most efficient way to access them. So the partition key is basically where it's stored, and the row key is the ID of that specific record itself. Yeah, so this is the actual update function. So this will again be triggered from a queue, and the update reaction is basically generating, so that's like I think 4 or 5 different functions which generate different reactions for us, and they are stored in the blob storage, which is accessed again by the web API we use. Yeah, that's in short the system we built. And what we discovered along the way is that we first try to move our own events which are happening within the application through the whole pipeline or through the whole thing. And we discovered that was taking way too long. So what we did was move them directly, so that's the line you basically see here, into the table storage. So that within the application or within the own domain, events could be processed quickly. And the events that are coming from outside, it's fine if we need to wait 10 seconds or so, because that's someone in another system clicking somewhere, and they're gonna get coffee or something to overcome that 10 seconds or the small delay there is. So this is in short what we built, and what we along the way of building this, we discovered that we had it working, and at some point we received a large load, and we discovered that we needed to use static HTTP, a static HTTP client, because if you use HTTP client and you do it each time over and over again, at some point in time the you don't have any more sockets to open, so everything will stack up. So that's one thing. We improved that by making it static. What was more things we discovered? Yeah, so the visible thing, we discovered, okay, we can simply make that longer. And I think the most fun thing we discovered is the pricing of it, which is, oh sorry, I'm skipping one slide. With what we also discovered after some time, or after a month in production, is maybe we need backups. Because it was running for a while, so oh yeah, maybe that's helpful. So what we did is we created a separate, to make the backups, we basically at that point in time discovered, oh, we have a lot of data now and it's not that accessible anymore, because you can only get things by the primary key, and we have a lot of primary keys now, so it took a long time to get everything, to back up everything quickly. So what we did for that is, as soon as the event processor starts processing one event, it will also store a reference in a different table or with a different partition key, and it will say, I have with this type, there is a reference, so customer 1. So for customers there is a customer 1, for customers there's a customer 2. And this allows you to use that table. We get it into a durable function, and it will fan out, so it will start up all smaller Azure functions, which will do the backup for a specific customer. That will fan out to a lot of Azure functions, or a lot of the same ones, a lot of instances, and go back again, and then the backup is done. And we discovered this is also very helpful for when we need to do, when we want to modify a projection, because a projection is simply some JSON in a certain format, and you have all the events, so everything that happened within the system, you have that stored somewhere else. So this allows you to build up from the events, from everything that happened, allows you to build up a view of what you want to show. So each, for example, each created customer, if you want to show a list for that, you would create a projection with customer 1, customer 2, customer 3, customer 5, for example. If somehow you want to store on a later moment in time, you also want to show in the UI the country from which the customer is from, you can simply run the events again if the country is stored in there, and basically create a different projection for that. But to do that, you need to know what are all the events I currently have within my system, and this allows us also to do that quicker and more efficiently. Yeah, so how much did this all cost? So this is from last month. We've been running in production for about 2 months, so we're listening to production events for 2 months now. And we spent, so last month we processed 1.6 million events. And you can see that this is when we implemented the backup. That's that spike. We went it for the first time, and you have some spikes of people importing large projects. So what you see is in the weekend it goes simply completely down. And the nicest part of it, our Azure Functions bill was 9€, which is not completely true, because you get like €6 for free from Microsoft. So that's €6.09. But that's a lot less than running a app service all day long. And you can see again, for example, here's the process event. So that was the first one. That's on average done within 180 milliseconds. We did around 500,000 of those. And there are some backup ones, but there are less of those because we didn't do many of them. They go pretty fast also, but I think that's because They are separate things, it's not the whole thing. And you see on projections, so the participants projection, which is all the people within a certain survey, that's a large one to build up, so that takes on average 7 seconds or so. But that's still perfectly fine for us. Yeah, there are some other sort of questionnaires built up within 1.6 seconds. And the main thing we discovered, which was very surprising to us, is that we spent most of our money on insights analytics, which is application insights. And we didn't log that much. The storage is also pretty cheap. It's going to be more because we're going to store more and more things. But it's still very cheap compared to running a SQL server and doing all those things. Sure, there are some.
It also depends on what kind of package you're running, right? Like standard, premium, etc.
Yeah, sorry, this is in the consumption plan.
Okay.
We only use the consumption plan for now. So that you only pay for the executions like 0.000 something cents.
Okay.
But if you do it in app services, then you pay for your app service, so it will go up. Yeah, that's I think all I got. Sorry, it's a bit short, but question, yeah.
How do you deploy this? Do you use Azure DevOps for this?
Yeah, we use Azure DevOps. We use I'm gonna cheat. We use a staging function, sorry. We use a staging function and we swap them around, right?
Yeah, we use ARM templates to deploy the function apps, so separate function apps, and then just the regular build and release pipelines to deploy our functions inside those function apps.
You create the entire structure with ARM templates?
Yes.
Okay. You use deployment slots to.
Yeah, you also create you can also create a stage slot or slots in function apps. And we deploy to a stage slot first and then swap it so it's sort of more
yeah.
And maybe because we can swap it back easily or something like that.
Yeah. And is there also some testing involved as part of the CI/CD?
You mean like integration testing?
Yeah. Yeah, and unit testing or function testing?
No, we don't. I don't think we have unit tests.
Yeah, we have run unit tests on them.
Integration tests, I think.
Yeah, oh. That's another thing we need to add.
Basically, when you have functions triggered by blobs or queues or something like that, you get this event-driven behavior that's mainly hard to test because a lot of things happen at the same time.
Yeah, so I think that's why we have a lot of application insights and logging, so we can really track exactly what goes wrong. And also our systems are really based on queues and stuff, so if a function doesn't execute, it will just retry again. But it will stay in the queue, so we can always, when there's a problem, we can fix it, and then it will resubmit the message again.
What I didn't tell is if anything fails, it will indeed try again. If something is locked, it will also try again. So this one, let me see, this one will simply get, if you add 1,000 participants in this table, or 1,000 records in this table, that one will also get 1,000 queue messages. What we do is we check what's in the queue, and you can ask for the top 32 queue messages. So we check is there something dull in there that we don't have it again, to simply clean it up front. But if that's not the case, then it will start the Azure function a few times too many, but that's fine. And it will try to do this. If it can't lock this one, it will try again. So there's retry logic in there, which doesn't help the testing, but it helps out with keeping things stable in production.
Yeah. These things are harder to test, right? Because logging and that's something that you need to force to happen on when you want to test it.
Yeah, the good thing is that the Azure functions themselves are very simple, so we can test the functions themselves, or at least the input-output parts of that.
It's just a matter of reading the event and writing it, well,
Yeah.
a little bit of processing and writing it.
Yeah, because the first few steps really don't do that much. They only take care of batching things up so we can, because we simply get spikes, so they batch up a lot. The even basically writing the projections themselves is something we're testing on probably, because we want to make sure that those are in place. But I think we can do that rather easily by either getting the logic out of the Azure function and testing against that, or trying to figure out if we can use dependency injection or something on the Azure function. Because we don't need to test we simply need to mock all those things out, because that's not our code, so we only need to test our logic, which isn't a whole lot as far as I'm the product owner now, but which isn't a whole lot code, but we definitely need to add testing to that, yeah.
What was the purpose of the 10-second delay?
We first started out with the topics, and we noticed that once you start processing service messages, there sometimes is a message that is swifted, so you have one that's later than the other in processing. I'm not sure why that happens, but it happens sometimes. And there is a book on enterprise patterns or something. It's in the marketing failure rates, which has 3 types of ways to process them. One of them is do them by the order number. So you basically batch them up till something is in order and you push that on. The other one is take a time frame and within that time frame order everything. That's basically what we're doing, because as soon as we insert things in this queue, so let's say for example customer 1, and we next to that add the ID of the queue itself, of the service bus queue, and that number is in order. So that will, if we query that back due to the how that works by default, it will give it back in the right order. We don't need to sort it. And we process it in that way. And we use that 1 second. So we said we are fine if everything within 1 second is at least in the right order. That was what we did at first. And we discovered later on, because we get large amounts of batches, large amounts of data very quickly after each other. So it could be once a day we get 100,000 events, but that's within a minute or so, and the rest of the day it's basically doing nothing. Depends on how active my coworkers are, because that's the moment they press save in another application. And what we discovered is, okay, if we extend this a little bit, things will go way smoother through the whole process. So we moved it from 1 second to order it and to batch it up simply to 10 seconds. Because within the system itself, it doesn't really matter if it takes 1 second or 20 seconds, as long as it's done within a minute or so. And this allows us to basically execute this whole line way less than, because otherwise we need to do that each and every second, and now we do it only once every 10 seconds for a specific customer. I'm not sure if that's explained correctly or understandable. But
yeah, kind of. I'm still a little bit curious if there's any risk of events not being in the right order at the 10-second mark. You know, that some events come after.
Yeah, that's.
Or supposed to.
Yeah, that's a risk we are willing to take. Basically, they can enter incorrectly in the queue. The only thing we're basically covering with that is a lot of Azure functions booting up and one being done quicker than the other. And so we're somewhat trying to get around that, and that's mostly in the range. We could fix that within the 1 second thing, because then in testing it didn't occur anymore. But we have that now more for the batching basically. So yes, it could happen, but that's a risk we're willing to take in this case. And they don't need to be, in most cases, they don't need to be exactly in order. What could happen if you, for example, post twice to a web API? There's also a risk that one will be done quicker than the other. if two people modify the same thing, for example. So that's somewhat the same thing as if I have one person and I try to modify that person from two places and those events come swifted. That's the same thing as a web API which, due to network latency or something, swifts around. So in that case we said, yeah, okay, it will probably happen, we will see. It's not a real answer, but that's what we made of it.
But if it happens, what?
In most cases, for now, it doesn't really matter because
you can trace it back.
We could trace it back and see, so in the original system, okay, what's the state it should be in.
Under control.
Yeah. But the cases in which this happens are so low because mostly we get a large batch of different participants and not a participant with name X and the next event rename it to name I. That's not something that will often happen in the same batch of things. So yeah.
I wonder, the way you do this, has it to do with GDPR maybe? So to analyze
for GDPR, we are ISO certified, so everything in here is encrypted. So that we do that by default, basically. But that's a different, completely different thing, and you need to be traceable, I believe. So this allows us to do that in some way, but that's more for the events happening within our own domain, and not so much for everything that comes from other domains, because they are the source of truth, basically. So we can also always ask them to.
So you do it for the sake of efficiency.
Yeah. Any more questions?
Yeah, I have a general question to assess the advantages of Azure Functions. If you would replace all your Azure Functions with your own RESTful API, then where do you see the main advantages?
You mean issues, right? Where would say issues or?
What are the advantages besides maybe the cost advantage that you have?
What we really like is the scaling of it. Sure, it has some delay in how it does things, but it will scale for you. So I write very simple code. That's not maybe a REST question, but if I have a web job which gets all those things and I kind of do those all in parallel or something, and I need to write all the logic myself, and now we simply write simple code and it will scale up for me, so I don't need to do that. If you look at this as a web API or a REST API, then it would be, to me, it would feel easier if it's one simple web API with a few functions than having different apps and different Azure functions that execute those things. But that's simply because I'm used to that.
Yeah.
But
but the web API, you could also scale that up, right, in the same way, or
yeah, you could.
Yeah. Is there a big difference in scaling function or a web app?
This feels like it goes faster, but I'm not sure. Or at least we have also web APIs which scale, and they scale per instance, and an instance will go, which might go a bit slower sometimes, but we don't really have those. For us, it doesn't matter how this thing scales as long as it happens. But there's no one waiting for this, basically. So it's we have no customer waiting for this to get feedback from the REST API. So
nice
yeah,
to have
you could.
Customers like that.
Sorry?
Nice to have customers like that.
Yeah. So we do have this thing where it talks to this is the front end. So this is the web API, which is the REST API basically. And what we do is we generate out those projections, which is basically this is the data and how you want to get it back. So it's simply going to blob storage, which is simple file storage, and getting back your data is extremely fast. That's way faster than taking 20 tables in a large SQL query and getting something out. Not that that is a good solution, but so in that way it will help you out. If you would replace this one with Azure Functions, with the consumption plan, then you might have the startup issues or the scaling, which was previously shown with the Spark, which is fixed in Premium, so I'm happy about that. So now we can try to move to that. Did that answer any more questions?
Do you manage all your Azure functions in separate projects? Or do you have them in one project?
We have them, each one is, so we have the projection functions are in one, and the backup functions are in one. Backup.
You mean it's all the same solution?
Yeah, solution and project-wise, you know, how are the functions distributed?
Well, it's all in the same solution. Yeah. So it's grouped
And then
together.
a couple of projects.
Yeah. So that web APIs and all the like application domain and the functions are all in one solution, and of course the front end.
It wasn't a lot of code, right? So.
No, it's. Do we have anything that I can show in there? Yeah, so here are the. Is this big enough? This is not. Visual Studio Code. No. I know how to do it with my mouse, but. Well, this one says backup, so that's the functions for backup. This one is a common one, which is as shared code. So here are the event processes, which are the ones that process all the events, the receiver itself, all the different projections. So here you can see the same ones as you saw in the logging or in the application insight log. These are all the integration events we get from outside. This is the testing project. So these are the tests for different unit tests for different things we have. And basically this is all, which now started running. This is all libraries we use within the web API itself, the bottom ones. So these. That's in short the project itself. Functions. We have tests for functions.
Yes, we do a lot.
So we have unit tests for functions. Yeah. Any more questions? Well, thank you all for joining. We still have some time. We still have some time. You can grab another drink, have a chat. We're here till 10, I believe, or 10 past 10. So enjoy, have another chat, and have another drink.
I have a short question.
It's a nice project.
Yeah.
I like it.
So,